Welcome to Lesson 89, Find Function Values of Algebraic Concepts. Okay, here's our objective. Here's our vocabulary. So what I want to say about the first word, relation. The X and Y are in a relationship. They relate to each other. And in particular on a graph, a line graph is what we see most of the time here in algebra. The relationship between X and Y is that X is the input and you had to do something to X and then you get Y as an output. So those points are related to each other to make a point. Those coordinates are related to each other to make a point into the coordinate plane. And once you connect the dots, you get a line or a shape, a figure on a graph. All right, here's some other things. So Y and f of x are the same thing. F of x, the variable, whatever variables are on the right side of f of x get substituted in. So sometimes there'll be more than 2 or 3 variables. But whatever is in parentheses, that's what gets substituted in. Some more vocabulary. Okay, so today we're talking about a little bit about slope. And so you take 2 coordinate points and you find the rise over the run. If you're given numbers, you're going to have to subtract the y coordinates and divide by the subtraction of the x coordinates. If you're given a graph, you just find where the line goes through the corner of a box. And this is what's important. The line goes through the corner of a box, and then you just count 1, and then 1, 2, 3. So the slope is the change in y, which is 1, over the change in x, which is 3. So we'll talk about that later. Slope on a table of values. Find the change in y divided by the change in x. So we see that the change in y is -5. The change in x is 1. So the slope is -5. The slope does not always have to be a fraction because we know that we can take a whole number and put it over 1 to make a fraction out of it. Okay, so you can read through that and share some rules and notes for you. And this is what a vertical line test is. A function is a function if the graph only hits a vertical line once. So as you can see with the top 3, you have functions, and the bottom 2, they are not functions because the vertical line hits the graph more than once. 4 types of slope. This is called a negative slope. This is a positive slope, and you can see the green words under it. Undefined. This is x equals something. So whenever you see x equals something, you will have a vertical line. A no slope or a horizontal line means y equals something. And in this case, 2, this is y equals 0 for your x-intercept, and x over here equals -2. We can figure out the slope from this line. Look at the corner of the box and the corner of the box, and we can see that it is 1, 2, 3, 1, 2. So you got -3 over 2. And for this one, corner of the box to corner of the box, 1, 2, 3 over 1, 2, 3, 4. So this is 4/3. That's the slope of that line. Okay, so let's do some examples. A water bill is computed by the formula where X is the amount of water in gallons and Y is the total dollars. What are the costs for 10,000, 25,000, 30,000, and 50,000 gallons of water? Okay, so here's our equation, and it's already written. 0.00165 X plus 1461. That's just some type of fee. Okay, so you can look at a water bill and see these kinds of numbers on there. All right, let's solve it on the next page. So as you can see, I already had it set up in a table of values. So all you're going to do is put your 00165 Put your 10,000 in and add 1461 to it. And then you do the same thing. Put 25,000 in it. And as you can see, the 0.00165 and the 1461 are constant. And the only thing that's changing is the x. And that's why it's a variable, because it can be any number. And this is why you have a water meter somewhere around your house, because this is how your water bill is actually calculated. I don't have the numbers that you have, but you can look on your water bill and see. So after setting this up in the calculator, our bill for 10,000 gallons of water is, let me pull up my pen. I'm sorry, I forgot to do that. Is 3111. And then we come down to 25,000, which is 5586. Then we come down to 30,000, which is 6411. And then we come down to 50,000, which is 9711. Okay, so let's look at our second value. Find function values for the following x's. I should have put an e in there, x's, on the graph. So y of 2. So we're looking at 2. Y of 2 is 1. And then the next one is y of 3. When y is 3, we got negative 1. See, when y is 4, we get negative 3. When y is 5, we get negative 2. And y of 9 is 1 again. So it's easy when you have a graph. You just find the points on the graph that you're looking for. Okay. What do we have here? Consider the function f of x equals negative 4x plus 11. Okay, so what are we doing here? We say f of 5 divided by negative 2. So what we're going to do is find f of 5. So we're going to substitute 5 in for f plus 11. We're going to put that in brackets, and we're going to divide it by 2. So negative 4 times 5 is negative 20 plus 11 is negative 9. Then divide that by 2 equals negative 9 over 2. And I'm just going to leave that as a fraction. I could change that into an improper fraction by dividing by 2. And we get negative 4 with 1 left over. Okay, 4 times the f of 3. So 4 times f of 3. Negative 4, 3, plus 11. So what you have to do is evaluate the function because we're given function values. And then go ahead and solve. Negative 12 plus 11, negative 1, negative 4 is our answer. So when you're solving these, when you're evaluating these or simplifying the expressions, do one step at a time, rewrite everything that's left over. That's a good habit to practice. A lot of people forget to do that, and they leave numbers missing and make mistakes. Okay, so let's look at example 4. Below is a table for function g, so it's already calculated. So what do we have to do here? All right, so g of 3 minus g of 5. Well, you have to calculate at g of 3, which is 0, and g of 5, which is negative 1. And then that gives you positive 1, because 2 negatives in a row give you a positive. Okay, so now when this is inside, you have to do the math on the inside. So 5 plus negative 2 is positive 3. And so now we're looking for g of 3, which equals 0. Now g of 2, I'm sorry, that should be a negative 2. G of negative 2, which is 8, divided by g of 5, which is negative 1, gives us negative 8. So when you see two g's, you're going to go ahead and evaluate the function at that point, and then do the math. When there's something inside the bracket, when there's only one g, add the numbers inside and then find the function at that point. So that's the difference between those. So those were 4 different types of examples. You will practice 4 different types of problems. And I will see you at the end of the video for a review. Okay, for f of x is 3x minus 4. Fill in the table of values from negative 2 to positive 3. So negative 2, negative 1, 0, 1, 2, 3. 3 times negative 2 minus 4. Negative 6 minus 4 is negative 10. 3 times negative 1 minus 4. Negative 3 minus 4 is negative 7. 3 times 0 minus 4 is negative 1, right? Nope. It's 3 times 0, negative 4. All right. 3 times 1 minus 4 is negative 1. 3 times 2 is 6, minus 4 is 2. 3 times 3 is 9, minus 4 is 2. And I'll show you a shortcut when we get to slope of a line. How to get through these fast. Okay, find the function values for the following x's on the graph. Okay, when y is 2, at y of 2, evaluating y as 2, you get 2. Evaluating y at 3, you get 12. Y at 4 is 7. Y at 5 is 8. And y at 9 is 6. Easy peasy lemon squeezy. Okay. Let f of x equals this function and g of x equal this function. Find the following values. All right, so here we go. G of negative 4. So we're going to evaluate g at negative 4, which is negative 4 minus 6, which is negative 10. Then we have to find g of 11, which is 11 minus 6, which is 5. Okay, so we take g of 4, which is negative 10, plus g of 11, which is 5, divided by 10. We get negative 5 over 10, which is negative 1 over 2, negative 1/2. And then problem 4. So f of 0 plus g of 0. So f of 0 is negative 7 times 0 minus 10, which gives us negative 10. So negative 10 plus, evaluate g at 0. And you see how I always put what I'm substituting in parentheses? And that way I never make a sign mistake. I may forget to put them in from time to time, but when you evaluate, and evaluate means to substitute a number in for your variable. When you evaluate, please put your substitution in parentheses. That will keep your sign straight. So thank you for watching this video. There are only a couple more left. I think there are about 20 left, so we're coming near the end of functions, especially linear functions, and then we'll move into our next topic.